Hello everyone. So now let's start our video lecture in continuity of the shapes of the ions. The geometry of some ions. Geometry of ions. Geometry में next our targeted molecule is chlorate perchlorate ion. Perchlorate ion. And the resonating structure and the structure of the chlorate ion is Cl O negative, double bond O, and double bond O. There is an 1, 2, 3, 4. 4 sigma and 3 pi bond. That means sigma bond, 4 sigma means that means sp3 hybridization, and total we need 7 unpaired electron. 7 unpaired electron, 4 for the sigma bond and 4 for the pi bond. Sorry, 3. 3 for the pi bond. So let's start with the electronic configuration of the center molecule, chlorine atom. Z equals to 17, neon 10, 3s2, 3p5. Ground state electronic configuration, 3s and 3p5, 1 2 1 2 3 4 5. Only one unpaired electron in the ground state. That means only one sigma bond or pi bond is feasible. One unpaired electron means only one sigma bond. But in the case of the perchlorate ion, there is an 4 sigma bond and 3 pi bond. We need 7 unpaired electron. That means all of these paired electron becomes unpaired, or all of these 1 3s and 2 3p orbitals become filled orbital becomes half filled atomic orbitals after the promotion of an electron from the ground state electronic configuration 3s and 3p to 3d. Excited state, 3s, 3p, 3d. Three S, 3p, 3d, 1 2 3 4 5 6 7. टोटल इलेक्ट्रॉन यहाँ पे कितने हैं? 7. और यहाँ पे भी कितने हो गए? 7 इलेक्ट्रॉन हो गए. हाइब्रिडाइजेशन क्या है? sp3 है. That means that is from sigma bond. That is sigma bond with O negative, sigma bond with oxygen, sigma bond with oxygen, pi bond with oxygen, pi bond with oxygen, and pi bond with oxygen. Oxygen. Clear? So Let's see. As we have seen that the electronic configuration of the sulfur atom in the excited state is the electron from 3s, 3s, 3p, 3d. Okay. This one is 3s, 3p, 3d total 1, 2, 1, 2, 3, 4, 5, 6, 7. 7 unpaired electron. One is involved in sigma bond. This is also involved in sigma bond. Okay. This is from sigma bond and this is from sigma bond. And these of the three unhybridized 3d orbitals form 3 pi bonds with 3 oxygen atoms. And the chlorine 1 3s and 3 3p orbital form 4 sigma bond by overlapping with 4 oxygen atom. This sigma, this sigma, sigma. Okay, tetrahedral, and only these 4 1 3s and 3p orbital involved in hybridization and form 4 sp3 hybrid orbital. That further form bond formation with an oxygen atom, and the perchlorate structure is formed. Next, in the continuity of the perchlorate ion, let's see the structure of the chlorate ion. Let's see the structure of chlorate ion. ClO₃ negative ion. Chlorine, oxygen, डबल बॉन्ड हो, डबल बॉन्ड हो, और एक यहाँ पे लोन पेयर है. That means 3 sigma and 2 pi. Total 5 unpaired electron required. ठीक है, that means 1 3s and 1 3p orbital electron are promoted to the 3d orbitals, and there is a 2 unhybridized 3d orbitals that forms 2 sigma bond with oxygen atom. Let's see how. Chlorine atomic number 17, neon 3s2, 3p5, ground state electronic configuration 3s, 3p5, 1 2 3 4 5, and this one is the vacant 3d orbital, and we need 5 unpaired electron. Excited state. Only these 3s, 3p, 1, 2, 3, 4, 5. Okay. So here, and this one is the 3D 5 bond menu, and the two unhybridized 3D orbitals form two pi bonds by overlapping with an oxygen atom, and the three unhybridized 3p orbitals form three sigma bonds with oxygen atom. This one with O negative, oxygen, oxygen, sigma, sigma, sigma. This one is the pi bond, oxygen. Okay, and this one is the third ones remain as a lone pair. This one as a lone pair. Okay, this one is oxygen atom. This one is an O negative. This one is an oxygen atom, because here is an 2s 2 2p5 2s2 2p4 2s2 2p4. This one has an lone pair. This one forms sigma bond. This one is also formed. This one is the sigma bond, and these two form pi bond. So here is a lone pair, but as I've already stated in many video lectures, that lone pair does not involve in predicting or in determining the hybridization, in determining the geometry and shapes of the molecule. So if you consider lone pair also, then is it tetrahedral? But as the lone pair is not considered, so the geometry is pyramidal. Hybridization is same sp3. So this is not द स्ट्रक्चर ऑफ क्लोरेट आयन क्या होगा, पिरामिडल होगा, बट इसकी ज्योमेट्री की अगर हम बात करें, ज्योमेट्री कैसी होगी, टेट्राहेड्रल होगी। ज्योमेट्री एंड स्ट्रक्चर में दोनों में डिफरेंस है। जब हम ज्योमेट्री की बात करते हैं तो हम लोन पेयर बॉन्ड पेयर सभी को कंसीडर करते हैं, बट जब स्ट्रक्चर या शेप की बात कर रहे हैं तो उस केस में हमें सिर्फ उसके बॉन्ड पेयर को कंसीडर करना है। लोन पेयर के बेसिस पे हम लोन पेयर को वहां पे कंसीडर नहीं करना। So this one is the case of the chlorate ion. This is almost similar to the perchlorate ion, only that this 3s electron is not promoted to the 3d orbital, so these electron remains as a lone pair. तो पिरामिडल यहाँ पे इसकी ज्योमेट्री रहेगी, और अगर आप पिरामिडल इज एन स्ट्रक्चर, अगर हम ज्योमेट्री की बात करें, ज्योमेट्री सेम रहेगी टेट्राहेड्रल, बिकॉज sp3 हाइब्रिडाइजेशन है, sp3 हाइब्रिडाइजेशन। So I hope both of the example you have clearly understood. First one is the perchlorate ion, and second one is the chlorate ion. Chlorate ion, and this one is the perchlorate. So thank you. Thank you for video lecture. Sorry, thank you for watching the video lecture.